Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue with similarity of triangles or similar triangles on page 137. So remember from the previous lessons from last week, we looked at congruency between triangles. We had 4 different conditions of congruency. And remember, congruent triangles are identical in nature. So their sides are exactly the same and their angles are exactly the same. Right, now we're going to look at similar triangles. So I want you to go to page 137 and follow me in the book. So on top of the page, we have 4 pictures of different, or of the same bird, but different images, okay? Different size images and different proportion images. So if we look at that, we can see that birds B, C, and D are similar to each other because they have been enlarged or reduced proportionately. This means that all the sides have been increased or decreased in the same ratio. Okay, so meaning that when we enlarge something, we enlarge the whole thing, okay, horizontally and vertically. Okay, an example I can give you is that if you go to your Word document, okay, so let's say this is my Word document that I open up. And what you can do is you can paste a picture into this Word document, whatever picture you paste, okay? Now, if you hover your mouse over that picture, you're going to find that there'll be little blocks on the corners of the picture, in the middle, and at the bottom like this. So I'll quickly draw them in. So basically, each corner will have a little block, and there'll be little blocks on the halfway horizontally and halfway vertically. Now, what you can do to that image, you can enlarge or reduce that image, but you can also go horizontally or vertically or both. So if you put your mouse cursor on one of these on the corners, right, one of these dots on the corners, it will allow you to drag the picture sideways like that, and it will enlarge the picture proportionately. Okay, so your image won't be distorted. It won't be stretched out either way. It will be dragged in proportion. Now, if you grab your image on one of these side bump thingies, what you can do is you can either stretch it horizontally or stretch it vertically. And when you go on the corners, you do it proportionately. Okay, so what we are talking about here is similar triangles is the ones where we enlarge or reduce them by pulling on the corner. So we enlarge the whole picture vertically and horizontally. So if again we look at the pictures B, C, and D, you can see they've been reduced from B to C to D in proportion. Okay, whereas picture A is the same as picture B, it's just been shifted horizontally. So A and B are not similar, but B, C, and D are similar images. All right. Now we can look at the next diagram in our textbook. So bird A is distorted enlargement of bird B as it has only been enlarged horizontally. Okay, great. Now, 2 triangles are similar if they are equiangular, so meaning that all the angles are the same in the triangle, and, or rather not and, their corresponding sides are in proportion. Okay, so what that means is that corresponding sides in proportion is that if I take one side of my triangle where I'm comparing it to another, so let me quickly draw an example for you. So let's say I have this big triangle like that, and inside I have a smaller triangle like that. Okay, so these 2 triangles are similar. Now the sizes, I could say that this is, let's give this size 10. Okay, that will be size 5. I'll give this size 8. This will be 4. And this one over here will, no, let's make this one a 6 and a 3. And this will be 8 and 4. Okay, so I've given you the sizes of these different lengths. Okay, so let's now give these letters A, B, C, D, E, F. Right, so now if we're talking about sides being in proportion, we're going to take the longest side, so let's say AB, divided by the shorter side of that triangle. So AB corresponds to DE, so we're going to say AB over DE, and that will equal to 8 divided by 4, which equals to 2. Okay. Right, then what we're going to do is we're going to take another side of the triangle. So I'll write it underneath here. So we're going to take BC divided by EF, okay, and that will equal to 6 divided by 3, which will also equal to 2, meaning that it's in the same proportion. The sides are in the same proportion, meaning that the smaller triangle, if we double the sides, we're going to get to the larger triangle. Okay, so all the sides have been doubled. Now, if we do the last side, AC over DF, we're going to find 10 over 5, which is also going to give us a ratio of 2. So basically, if all the sides are in proportion to each other, meaning they're equal to the same ratio, that means the two triangles are similar. Okay, so there's again two ways to prove two triangles similar, is that if they are equiangular, all the angles are the same, or all the sides are in proportion. So either one of those is enough to prove that triangles are similar. Okay, right, let's look at the proof. So in triangle ABC and triangle ADE, so we're looking in the textbook at the red and the blue triangle, we have angle A is a common angle. Okay, so they both share angle of 20 degrees. Angle B equals to angle ADE. Okay, so angle B is 118 degrees and angle ADE is also 180 degrees. So now that's two angles that are the same in these two triangles. And we have angle C, which is 42 degrees, which equals to angle AED, which is also 42. So we've shown that three angles are the same in these triangles. Therefore, we can conclude that these two triangles are similar. Okay. Now we can use the second approach. We can say dividing the sides in the correct way gives the following. So longest side of triangle ABC divided by the longest side of triangle ADE, which equals to the middle side of ABC over middle side of ADE, which equals to shortest side ABC over shortest side ADE, which equals to 80 over 60, 60 over 45, 32 over 24, and they all can be simplified to a ratio of 4 over 3, which means that these two triangles are similar. Okay, so guys, that's pretty much what I've done on the board over here, showing you the different sides in the ratio. So they've just written it out for you on page 137. So it says this constant result indicates that the corresponding sides are in the same proportion. So there are two ways to prove that two triangles are similar. One, show that they're equiangular, or show that the corresponding sides are in proportion. Now, what way do you use? Well, it will depend on the question. Either we'll give you information about the angles that you can use to prove similarity, or we're going to give you information about the distances of each side, which you can use the ratio method to show me that it's the same ratio, therefore the two triangles are similar. All right, cool. Let's go to the next page. So here we have a worked example. It says AD and BC intersect at E with AB parallel to CD. Okay, I'm going to draw this quickly. I'm going to try to use another marker because I think that one is a little bit too thin for you guys to see. All right, so we basically have two triangles that are doing this. Okay. Okay, the marker is also running out a little bit, so it should work. Right, so we have two triangles like that. They give us that the points are A, B, C, D, and E. All right, and then this is angle 1 and 2, and they say AB is parallel to CD like that. Okay. Right, so they say AD and BC intersect at E with AB parallel to CD. Great. Number one, prove that triangle ABE is similar to triangle DCE. Now, guys, when we look at the symbols, now congruency symbol is a triple equal sign, okay? So meaning that the triangles are identical, they are equal and identical, okay? But for similarity, it's a triple sign going vertically. Okay, so when they say show me that it's like that, it means similar triangles when there are 3 bars. When there's only 2 bars, it means parallel lines. Okay. Right, so first they want us to prove that these two triangles are similar. Right, we can use two methods. Either we prove that all their angles are the same, or we prove that all their sides are in proportion. Right, what information were we given? Well, we were given that there are parallel lines. Okay, remember parallel lines is alternate, co-interior, and corresponding angles. Okay, angles. Then we also have these angles over here, E1 and E2. What we don't have is any distances anywhere, okay, meaning that we can't use that approach at all, even if we wanted to. So the approach that we have to use here is proving that the three angles are exactly the same. Well, can we do that? Well, yes, because we have alternate angles. We have two z's going, so this angle is the same as that angle. This angle is the same as that angle because of alternate angles and parallel lines. And these two angles are equal because of vertically opposite angles. Okay, so it's quite easy to prove that these two triangles are similar. So let's do it. All right, so first we're going to say E1 equals to angle E1 equals to angle E2. What is our reason? It is vert op. Okay, vertically opposite angles. Okay. Second angle, we have angle C. So angle C equals to, okay, and I can use the notation of angle C because there's no other angles associated with C. So there's really only one angle that I'm specifying. So, or you could use a three-letter notation, that's also fine. Okay, so angle C equals to angle B. Why? Alt angles. Which lines are parallel? It's AB. Parallel to CD. And then we have angle D is equal to angle A for exactly the same reason. Alt angles, AB parallel to CD. Okay, cool. Once we've proven the three things or three angles are the same or the three ratios are the same, then we can conclude why these two triangles are similar. So we're going to say, therefore, triangle ABE is similar to triangle ECD. Okay, and that's how we conclude. All right, so, and then the reason for this, remember, we only have two options. Either angle, angle, angle is the reason, or all the sides are in proportion. So the reason for that is sides in proportion. So you're going to write that out. So here, we're going to say reason, angle, angle, angle. Okay, in brackets. All right, cool. So that was pretty straightforward. Now, number 2 says if AB is 4 units, AE is 3 units, CD is 8 units, and CE is 4 units, calculate ED and EB with reasons. Okay, so let's figure this out. Let's first put all this information on here. So it says if AB is 4 units, okay, so that's 4. AE is 3 units. AE is 3 units. Okay, CD is 8 units. CD is 8. And CE is 4. CE, this is 4. Okay, what they want us to find, calculate ED. Okay, so that's the distance that we need to get. Okay, now the idea here is that, let me just rub this out quickly. The idea here is that we've already proved that these two triangles are similar. If the two triangles are similar, that means their sides are in proportion, okay? So if we can find out what that proportion is, we can find the missing lengths of this triangle. So meaning that we need to match up the longest side of AB to the longest side of CD, and they've given us those, okay? So what we're going to do is we're going to say that CD divided by AB equals to 8 over 4, which equals to 2. So the ratio of the bigger triangle over the smaller triangle gives us a ratio of 2. Right, well, let's figure this out. So we have which angles are the same. So this angle and that angle are the same. So basically this side corresponds to that side. This side corresponds to that side. Okay. So we have this side CE over EB equaling to the ratio that we got before, which is 2. Okay. But we already have the side CE, which is 4. So I'm going to put 4 over here. Okay. And now I need to solve for EB at the bottom over here. So what we're going to do is we're going to multiply both sides by EB. They would cancel on this side. So we would have 4 equals to 2EB. And we divide both sides by 2. So divide 4 by 2. We're going to get EB equals to 2. All right, so this side is going to be 2 units. So if this is 4, that is 2. Okay, so you can see the relationship. So to get from the smaller triangle to the bigger triangle, we have a ratio of 2. So we multiply by 2. So the same thing is happening over here. All right, so let's write that out. So we have the bigger triangle, which is ED. Rather the side ED from the bigger triangle, divided by 3 must equal to the ratio of 2. Okay, multiply both sides by 3 and we get that ED equals to 6 units. Okay, so we kind of work backwards because now instead of me saying here's the information, prove that these two triangles are similar, I'm saying to you these two triangles are similar. Okay, given that, find the missing sides. And the idea is that you need to find the ratio because the triangles are similar from the information that I give you, and then work backwards to find the missing sides. Guys, it's a very common question. It comes up all the time. Okay. And if you look at in the answers in number 2, they've done exactly that. So they've written out all the sides saying that they are all equal. They filled in the values and they basically concluded that DE is 6 and BE equals to 2. All right, so we're going to, let me see if we have time for next example. Guys, I think we're going to, okay, let's quickly do it. And then you guys can do 13.8. So the following example, it gives us the different sides of the triangle, and it says prove that ABC is similar to triangle DEF. All right, in the previous example, they've given us all the angles, or we could get all the angles. Here, they're giving us no angles, but they are giving us the different sides. And what they've done nicely for us is that they've color-coded these sides. Okay, I'm not going to color code, or the textbook is not going to color code sides for you or the exams, but here they're basically guiding you through it, showing you which is the longest side, middle side, and the shortest side. All right, so for this example, let me quickly draw this. So we have one triangle inside another triangle, pretty much what I started this lesson with. Okay, and they give us sides 45, 60, 90. And 15, 20, 30. Okay, and the sides are A, B, C. So A, B, C, D, E, F. All right, so we have all the information about the sides. What we need to do is show that they are all in the same proportion. Okay, well, let's do that. Let's start with AC. So AC over DF equals to what? So that over that. 60 over 20, which equals to a ratio of 3. Great. Let's do the next side. Let's do AB over DE. So AB over DE equals to 45 divided by 15, and it also gives us a ratio of 3. Great. Let's do the final side. We have BC. Okay, this pen is running out. Let's try another one. Okay, that's much better. We have BC over EF, which equals to 90 divided by 30, which is also 3. Okay, so once we've showed that the 3 pairs of all the sides give us the same ratio, then we can conclude that 2 triangles are similar. Okay, so we're going to say triangle ABC is similar to triangle DEF. And what is the reason for that? Remember the previous one, it was AAA for angle, angle, angle. Here we have sides. So the reason is sides in proportion. Okay, sides in prop or in proportion is fine. Okay. Right, guys, so, all right, let's see what they say. Do not replace sides in proportion with SSS, as this is used in congruency. All right, cool, guys, that's very important. So you can abbreviate proportion with prop, but don't say side, 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 because that's a congruency condition. In the congruency conditions, we don't have an angle, angle, angle. Okay, so that's why it's okay to use it for the first one. For the second one, it's sides in proportion. Write it out in full. All right, guys, what I want you to do for homework is 13.8. So there you're going to prove that the triangles are similar to each other. So that's question 1 and 2. And in the next lesson tomorrow, we're going to continue with geometric, or actually on Friday, I think, we're going to continue with geometric problems on page 140 and 141. Okay, guys, thank you. I hope you enjoyed the lesson, and I'll see you next time.